Today we would like to solve the concept related to digital electronics, related to digital signal, it's a digital system designing. So for that, we have concentrate on the basic Boolean law, which is known as Boolean algebra. And after completion of that, we have concentrate on the K-map, Carnot map for the three variable. If functions consist of three variables, at that time Carnot map concept can be used. How Carnot map concept can be utilized, that we have discussed with the help of K-map. So concentrate here. First of all, we have understand the concept related to digital electronics. So I have right here digital electronics. In digital electronics, we have discussed the first topic in this lecture, which is known as Boolean law. Fundamental law, we can say fundamental law. Now, this Boolean law that can be operated with the help of basic logic level, which is known as 0 and 1. 0 means what? It is considered as a low logic, and 1 means what? It can be considered as a high logic. So now, suppose consider any particular function a. It consists of variable a that can be multiplied with 0, then answer is 0. Now a that can be multiplied with 1, then answer is 1. This is the first law, this is the second law. According to book, this law may be variable. Some of the law that can be mentioned in different way, but concept remains same. So now a plus 0 equal to a. Fourth, a plus 1, a plus 1 equal to 1. Why? Because maximum value is 1. Now, fifth, a plus b all dash, which is equal to a dash dot b dash, which is known as De Morgan's theorem. And a dot b all dash equal to a dash plus b dash, which is also known as De Morgan's theorem. First of all, I have mentioned this is the subject which is known as digital electronics, or we can say digital system designing based subject. Now see, this is the different law. A plus b all dash equal to a dash dot b dash. Change the sign. I have right here. Break line. Break line. Change sign. And here, change sign. Break the line. So a plus b all days equal to a dash dot b dash, and a dot b dash equal to a dash plus b dash. It is the fundamental law, dotted line I have mentioned here, which is also known as De Morgan's theorem, which is also known as De Morgan's theorem. So this, it is the fundamental theorem related to that particular point. Now we will derive the De Morgan's law with the help of logic level. With the help of logic level, we will derive the law. So share the whiteboard here. I have enlarged. We will prove that, we would like to prove that, hello, hello, hello. We would like to prove that De Morgan's law De Morgan's law. So here we can say a plus b all dash equal to a dash dot b dash. We would like to prove this theorem. So first of all, take the rectangular table. Now, now, consider here consider here input A, here B, here A plus B, here A plus B dash, and here consider A dash, and here consider B dash. So here see here I have write 00011011. 0 plus 0 equal to 0, 0 plus 1 equal to 1, 1 plus 1 equal to 1, 1 plus 0 equal to 1, and 1 plus 1 equal to 1. Here, what is the complement of 0? It is 1. What is the meaning of that? If input A equal to 0, then A dash equal to 1. And if A equal to 1, then a dash equal to 0. So it can be considered as a one type of complement statement. See this very carefully. It can be considered as a one type of complement statement. If a equal to 0, then a dash equal to 1, and if a equal to 1, then a dash equal to 0. So here 0 plus 1 equal to 1, so complement of 1 is 0. 1 plus 0 equal to 1, so complement of 1 is 0. And 1 plus 1 equal to 1, so complement of 1 is 0. This is a plus b all dash. Now see this a dash dot b dash. What is the complement of a? 1. What is the complement of 0? It is also 1. Here 0, here 0. What is the complement of b? 1. Here 0. Here also 1. And here also 0. So what is the answer? If you can multiply with each other, multiply with two columns. So here we can get 1, here 0, here 0, here 0. Now if you can see this table, consider this is table 1, table 2, column 1, column 2, column 3, column 4, column 5, column 6, column 7. So compare column 4 with 7. So both are equal. Both are equal with each other. So here we can say that a plus b all dash, which is equal to a dash dot b dash. De Morgan's first law that we have proved here. De Morgan's first law that we have proved here. Now, what is the second law of De Morgan's theorem? This is the first law. I have completed that. Second law of De Morgan's theorem, I have right here. A dot b all dash equal to a dash plus b dash. It is the second law of De Morgan's theorem. Now see, I have sketched the vertical line. Now see, here it is A, here it is B, A dot B dash. So here we can say A dash, here we can say B dash. So here we can say A dash plus B dash. We would like to obtain the equality between them, nothing else. So here we can say 0, here also 0, 0, 1, 1, 0. 1 1. Now 0 into 0, answer is 0. But what is the complement of 0? It is considered as a 1. So 1, 0 into 1, answer is 0. So what is the complement of that 1? 1 into 0, answer is 0, but what is the complement of that 1? And 1, 1, answer is 1, but what is the complement of that? It is 0. Now, what is the complement of A? 1. What is the complement of A here? 1. Here 0, here also 0. Here 1, 0, 1, 0. Now if you can multiply, if you can add with each other, 1 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0 equal to 0. Now if you can compare with each other, see this. If you can compare, then we can say A dot B dash equal to A dash plus B dash. So it is the basic law that we have required to prove here, which is known as basic fundamental law related to digital Boolean expression. Now we have solved the example. Related to basic fundamental law of digital electronics. F equal to function ABC, which consists of three variables. Example, A dash B plus B dash A, B dash A dash plus A dash B C plus A dash B dash C plus A dash B plus A dash plus AC. Simplify this function using basic law. Simplify this function using basic law. So what is the answer? A dash B plus A dash B dash. See this. I have write with different pen. F of A dash B plus A dash B dash plus A dash B C plus A dash B dash C plus A dash B plus A dash plus AC. Now see, consider first two term. If you can take common A dash, then we can say B dash plus B, B plus B dash. Plus, consider another term common, A dash C. So again which is known as B plus B dash. Plus, A dash common B plus 1. See, consider this is the second term. Consider this is the third term. I have sketched with different pen. And this fourth term can be considered as a separate term. So here AC as it is. Here it is considered as a third term. Here it can be considered as a second term. Here can be considered as a first term. Now A dash common. B plus B dash equal to 1. Why? Why? Because B plus 1 equal to B. And what is the complement of B? Which is known as B dash. Complement of B. Complement of B equal to B dash. So here B plus B dash equal to 1. Why? Because if B equal to 0, then B dash equal to 1. So 0 plus 1, obviously 1. So we can say that B plus B dash equal to 1 plus A dash C plus, here also it can be considered as a 1. Here A dash B plus 1. B plus 1 equal to B plus AC. This is the final expression, final last expression, f of a comma b comma c. B plus b dash equal to 1. B plus b dash equal to 1. Why B plus b dash equal to 1? Because if b equal to 0, then b dash equal to 1. So b plus b dash, which is equal to 1. B plus B dash, which is equal to 1. So here A dash, here A dash plus A dash C plus A dash B plus AC. It is the pre-final expression. It is the pre-final expression. Please carefully see this very carefully. Now, now I have erased this portion. So, last expression, f of a comma b comma c equal to A dash plus A dash C plus A dash B plus AC. So if you can take common A dash, so C plus 1 plus A dash B plus AC. What is the C plus 1? C plus 1 equal to C. So A dash C plus A dash B plus AC. Now if you can take C common from this term, C can be considered as a common. So final answer is C plus A dash B. C plus A dash B, it is the final answer. So I would like to erase this portion. Again repeat, this is the pre-final expression. Again, this is the pre-final expression. So f of a comma b comma c, which is equal to c plus a dash b. This is the final answer. So here pre-final a dash c plus 1, which is equal to c a dash c plus a dash b plus ac. So here we can take from this term, we can consider a dash as a common, so c plus 1. So a dash b plus ac, a dash can be considered as a common from first and third term. So c plus a dash b, it is the final answer of that particular example. So based on that, we have solved this Boolean expression with the help of Boolean law. There are so many examples based on that particular law. Now I have discussed the second example, last example, f of a comma b comma c equal to a dash b c a b c dash plus a b c plus a dash b c a dash b dash c. Now simplify this function. Question asked like that. Simplify this function. So what is the answer? What is the answer? What is the answer? F of a comma b comma c equal to a dash b c plus a b c dash plus a b c plus a dash b dash c. Now see, consider this term and consider this term. BC is common. So BC common, bracket my a dash plus a plus here a, here a dash, here b dash, here c dash, here c. So here can we consider a b c dash plus a dash b dash c. So a dash plus a, which is equal to 1, plus a b c dash plus a dash b dash c. So now consider b can be considered as a common. So b common, bracket ma c plus ac dash plus a dash b dash c, which is considered as a final answer, which is considered as a final answer. So it is known as second example related to simplification of law. Thank you very much.